Got it. So we have imported the green taxi data. Green taxi data, New York City. January 2017. Because this is large data. After that, they gave very small data sets. So we have imported the libraries, we have set up the working directory. Then we have imported the data using low memory is equal to false because we have lot of data. And then we found out the shape of the data as 10,760, 19 variables, vendor ID, trip type, tip amount. So what do you need to predict here? What do you need to predict? Tip amount. Tip amount. Okay. So this is the D types, right? Now, one interesting thing is that info. So in info, e-hail is a completely null object, right? E-hail fee is completely null. So if you do the info on the data, you can see that e-hail fee we can drop outrightly because it's gone zero. It's 100% gone. So we can outrightly the info command you always run on large data. Info command will give you the chance to find out those 0 columns which are there and you drop them. So here we found out that e-hail fee is completely 0. So green taxi is equal to green taxi dot drop e-hail underscore fee comma access is equal to 1. E-hail fee is 0. There are 0 data in e-hail fee, so we are dropping it. So we are dropping e-hail fee because there is 0 data in e-hail fee. As per the info, we found out that e-hail fee is 0 data is available. And there are no missing values, right? Nah, because everything is non-null. Info is clearly showing us that everything is non-null. Okay. So drop to the column as no data present in the column. No data is present in the column. Now, next thing is the object columns. The 2 object columns, actually there are only 3 object columns, right? Store and forward flag and drop off time and pickup time. But these 2 should not be treated as objects. They have to be converted to dates. So the second step is convert dates into date time format. So we have to convert the dates into date time format. Green taxi dot what was it first one? Is equal to pd dot to underscore date time comma errors is equal to coerce. See, there are a lot of libraries also available for Datetime, but the best is PD2 date and range because it automatically does the formatting. Green taxi dot is equal to PD dot to underscore Datetime green taxi dot comma errors is equal to coerce. Now I'll go up and run the info command again. Now see, they have been changed to Datetime. Datetime automatically done. See, Datetime 64 nanoseconds. What is the other column we have? Store and flag it. I think it's same, right? Or it has a unique value? Huh? Yes, no. Very low. 1700. Now, using these two columns, we can create a new variable travel time, travel underscore time. Travel underscore time, I think it is calculated in minutes, right? Yes. We can create a new variable called travel underscore time. Then we can delete the dates. Of course, we have to extract some other information and then we'll delete both the date columns. Huh? Dates also we have to extract. We'll extract. The most of the work extraction is done on dates only. So, sorry. So, how will you calculate the difference? Simple. Green taxi, square bracket, single quote, travel underscore time, the new column name is equal to green taxi dot lpep pickup date time minus green taxi dot what time? Drop time, right? Drop off time. Green taxi dot head. Sorry. Travel time. Oh. Why it is coming minus 10 plus 23 hours? Yeah, hello? Hello? Hey, why it came like this?
Sir, most of them is 24 GMT formats. So it's not in 0 to 12. It's 0 to 24.
Yeah, whatever it is.
And there are
sorry, I am reversing it here. Shit. Drop of time minus pickup time, na?
drop off minus pickup.
So I am reversing it. That's why I got the minus green day taxi dot pickup time, right? Now we got the time. 9 hours, 50, sorry, 9 minutes, 50 seconds, 5. Now we have to format it into time, minutes. Where there are hours? 23 hours, 59, 454.
The taxi driver is taking the trips whole day.
Whole day. Okay.
Taxis are booking.
Min is 0. Max is. Now, did you convert them?
Sir, I used in a simple manner, sir. I expected hours and I converted that hours into minutes and I added the minutes into same place. Like in manual method. Like
No.
okay.
Convert time delta hours to minutes. Python. But we got time delta in hours, right? Or let us say we convert it into hours. Okay, so what we got is type of green taxi dot travel time. It's a pandas code data series. green taxi dot travel time dot describe. D type is object. Nobody answered to this, huh? Check. You can use dfdt dot to underscore seconds by 60. Okay, I think we have to use this one only. dt dot total seconds.
Then we import the library.
Green, no need of importing library.
Import time and speed.
1 second.
It's a pretty-
Travel time is equal to green taxi dot travel time dot dt dot total underscore seconds divided by 60.0, right? That's what this guy gave, right? Dt is total seconds is automatically read, right? Now green taxi dot travel time dot describe. So it converted into minutes. If you want to convert it into hours, 3,600, right? 60 into 60, 3,600, right? That would be a better option, right? Minutes will be better option. This is in minutes, right? So np dot round comma 4. It is 2. Yeah. So 19.44 is the lowest minute, maximum is 1439 minutes. 1439 minutes is the maximum. That's what, no? Okay, so now we have done the date time fixation. You look at all of you get this command. Real taxi travel time dt dot total underscore dt are internal commands now. Pandas date time. 2 underscore date range is also same. So once you convert it into minutes, which one? The top one. Huh? We have new variable. Yeah, this one. So let me remove this. This is of no use. Okay, and then you look at this code. So this is the difference between drop time and pickup time. I am putting it in 2 lines, but you can type it in 1 line and then convert it into minutes.
20 minutes. Yes, sir. 1.2929 is round to 1.22.
For E plus Nara, that's what we are trying to do. We are converting it to decimals. Rounding up to 2 decimals. Other E plus 0 1 either you will get confused. Guys, take your break online. Okay. So we have created a new variable. Guys, online you guys are back. So we converted the time into minutes. So just check green taxi dot travel underscore time dot d types. Float 64. Data type is float 64 only. So we don't have any problem. Even if you don't round it also, it will take. But round up is for our understanding. Now we will. No. It's only for visualization only. It will not change the backend data.
But we can say.
Huh? Change. You can say travel time is equal to nb dot round and comma 2. Then it will change. Extract information from date as new variables. As new variables. So everything is for only 1 day, right? Date is 1 day or 2 days? I think it's only 1 month. 1 month is there. Okay. So we have to extract, what we can extract is weekday. Weekday we can extract, week number. Yeah, we can extract. Then hour of day we can extract. What else you can extract? Weekday, week number, hour of day. Any other thing? Month day. Day of month also we can extract, right? Because this is a 1 month data. Day of month, right? Data is for 1 month, right? We can also say is month start, is month end. This also we can extract, right? Month starting and month ending also. So Boolean variable, yes. So we can all extract this from pickup time. We have to extract it from pickup time. Because for exploratory data analysis, I want to know the demand. Which weekday demand is high? Is the demand is high on Sundays, Mondays, Tuesdays, Wednesdays, Thursday? During which hour the maximum demand is there? During which week of the month it's there? Is that day month beginning or month end? Because month end people might not have money, they may not pay you tips. Right? That is important, right? Month beginning, they might have money, they may pay you tips. General logic, but is it so? We have to find out. That we have to find out. So we have to create these variables. These are the new variables which we are going to create based on the pickup date time. So we will use pickup time, date time, pickup date time as the point to extract this. So green taxi square bracket day of hour. Sorry, hour of day. Hour of day. We have 24 hours, right? Is equal to green taxi dot pickup date time dot dt dot hour. Dt dot hour only, right? So we have dt dot hour. We don't have hour of the day, right? Only dt dot hour is there. dt dot tab day name hour is there, right? Okay. dt dot hour. So green taxi dot hour of day dot value underscore counts. So we have 24 hours, right? Till 23 we have 0 to 23 hours. 0 to 23 hours we can check the date. So we have the data 0 to 24 hours. Green taxi weekday is equal to green taxi dot pickup date time dot dt dot day name. That's what we want, day name only. So green taxi dot weekday, sorry, dot value underscore counts. Okay. No, we didn't get anything here. Name weekday. So we have to change it. dt dot day of week or weekday. Weekday. So weekday is coming in numbers.
Yes, sir, because 0 is the Sunday. 1
Sure.
is the Monday, like that, up to 6.
Is it 0 to 6? 0 is Sunday? Confirmed?
Yes, sir. Because Python also covers that.
0 is Sunday, 6 is Saturday, right? That's what I got doubt. Monday to Sunday. Monday to Sunday. So this is 24 hours. This is 0 is Monday, 6 is Sunday. Square bracket, sorry. Green taxi, square bracket, single quote. We then said week number, right? Week number in the year. Week number is equal to green taxi dot pickup date time dot dt dot week of year. Week of year. Okay, it is saying use ISO calendar dot week. dt dot ISO calendar dot week. ISO calendar dot week. Okay. So green taxi dot week number dot value underscore counts. 1, 2, 3, 4, and 52. Oh, this is January data, na? So prior date things also will be there, na? December data might also be there. December, then why it says 52 is also found?
It's about only January from 1 day to 31st day.
Okay, then gt dot week of year. Then let us see. Still we are getting there. There might be some reference to December somewhere. That's 52th week means last week of December. In a year, how many weeks we'll have? 52 weeks, right? And 5 weeks is January. That's correct. So it's correct only. So there might be some reference to previous day, midnight. Sometime they might have picked up one day before. Drop time is important for these guys, na? They might have picked up prior night, last hour, 11 to 12. Sometime they might have picked up, which they are dropping after 12 o'clock.
But I have checked in multiple times by handing out the samples. So it seems like
No, now you will not see because both the functions are giving us 52 week of the previous year. For week, January generally has 5 weeks. That is confirmed. Okay. Okay, we have got the week number. Then what we need? Weekday we got, week number we got, hour we got, day of the month. So green taxi square bracket day of month is equal to green taxi dot pickup date time dot t dot day of week, day of year, days in month. Day name or day? Yeah. dt dot day is giving day of month. 31 is there. 31, yeah, is there. 31, 1 is there. dt dot day. Day of month 1 to 31. dt dot day, day of month 1 to 31. Then square bracket is month start is equal to green taxi dot pickup date time dot dt dot is month start is month start. Green taxi square bracket single quote is month end is equal to green taxi dot pickup date time dot dt dot is month end is month end, month start and month end. So we have extracted weekday, week number, hour day, day of month, month start, month end. These are the new variables which I have created to understand the demand. So because these variables will play a very important role, right?
Sir, in week number that 52, the count is 40,938 rows. So what it means?
Last day of the year of the previous month, 31st January.
So
31st December.
2016.
Yeah, 2016, 31st December. Drop off might happen after midnight, which will come under current year. First 10 days. First week, I think. Just check. Ah. You can check it. Check in the dt.is month in Python, you'll get it. Is month start. So either it should be 1 to 7 days or 1 to 10 days. What is the time frame? So month start and month end also plays a very important role in demand analysis. So just let me check. Python dt dot is month start. First 7 days, huh? No, that for that there is a first day of month is different. So 1 second, datetime module. No. Unit underscore. datetime module में module calendar is underscore month underscore start. Okay. Got it? We have extracted these variables from the date time. And location ID, drop location ID, pickup location ID, rate code IDs, anything there? Rate code ID, PU location, pickup location ID, and drop location ID.
And EO location ID.
Drop location.
But the IDs are included.
Obviously. Now, tip amount analysis. So, tip amount analysis. We will start with tip amount analysis. Okay. So, we will do average comparison. Average comparison we will do. Okay. Trip amount analysis. This is very important because that is the dependent variable, right? Or you can also have trip amount as dependent variable also. Trip amount is also there, no? Dependent variable can be tip amount or total amount. Anything. So let us analysis on tip amount as the dependent variable. Okay. So the question is, what time of the, what hour of the day? What hour of the day most tip amount paid on an average? On an average, what hour of day most tip amount is paid? So green taxi dot tip underscore amount dot group by in brackets green taxi dot hour of day, right? Dot mean. So we got the tip amounts based on the hours. You have used SNS plots, right? For labels. For adding labels, you have used SNS plot. It is easy for normal plot we can't do. We are not getting the bar labels, but in an SNS plot we are getting it. Okay.
And it's very interactive in the
Okay. Okay. So because that is easy. Yes. Okay. No. But see, I need the labels. That is the most important thing because all the numbers are closer here. So when you have all the numbers stacked up like this, when you're not able to make differences, you have to plot it as bars. When you're plotting it bars, the bars will be of almost equal height. So we need to get that marginal differences. So for the plot, what we can do is import Seaborn as SNS, right? Shall we give a name to this and then we will plot it, or we have to name this thing, right? Then only we can plot it into SNS. So hourly tip is equal to this, right? We have shown it, stored it as hourly tip. Import cbound as SNS. So SNS dot bar plot, bar plot hourly trip what is do labels, labels. No, there is no labels here. Okay. SNS bar plot with values. How to show values on cbound bar plot? We have values function, huh? No. Oh, we have to use this one. AX dot containers. We have to name this also, right? Our AX is equal to this, but for our AX dot containers, our AX dot bar underscore label I. What happened? Hourly tip, okay. Hey, we didn't get it properly yet. Huh? Oh, here he got it, I comma. No, group by, I think we can directly give. We have done the group by, right? So I think we have to use this one. Our X dot bar label, our AX dot container 0. No. Why we are not getting it? X and Y देना पड़ता है क्या? Comma X is equal to our, Y is equal to tip amount, right? Y, right? No. We have to do the group by, right? And then we have to give the group by output. Hour of day And then there is no column names, right? What is this guy to group by? Data is equal to, we have to give, yeah. You're right. You have to give data is equal to. No. Here we have to give a bar plot. See, in the bar plot, he has given, see, data is equal to grouped values. So we have to give data is equal to hourly traffic. Sir, hourly tip. See, hourly tip dot tab. What are the column names we have got in hourly tip? Just check. Hourly tip dot columns. Okay, we'll do one thing. PD dot data frame hourly tip dot columns. See, hour of the day and tip amount. We have to reset the index also. We have to reset the index also. So just let us do it, then we can get it. So hourly tip is equal to green taxi. These are the column names. Tip underscore amount is the value. So here he has said reset underscore index also. So dot mean and reset index also. We have to give the second command also, which is reset index. Dot reset underscore index. Right. See, hour of day and tip amount. Now we got it.
Then x equal to hour of day and y equal to tip.
Yes. So simply, if you say hourly tip, how much, what output we get? So hourly tip also it is coming like this only.
But we have converted it in data.
We didn't. Okay, let us see one thing. See, it is coming like that only. Even if I didn't convert it into data frame, I read on the command again. Okay, so we got the hourly tip.
Because of the index.
So hourly tip dot container 0. We have to give x equal to, right? X is equal to day of hour of the day, right? Hour of day. Y is equal to tip underscore amount, comma, data is equal to hourly tip.
First hour tip is
Which one?
then hourly tip.
No, we have to give that also, no? No. Oh, okay. Yeah. Now we got the bar plots.
So we can increase the size.
Yeah, we can increase the size, but we don't want this text box. So, comma, right?
In outside say one semicolon is
Which outside this place?
after the brackets, parenthesis. Sir, after the parenthesis.
This place?
Yes.
Semicolon or colon?
Semicolon.
Yes. Now we have to do the other part. PLT dot figure is equal to fig size is equal to 15, 10. Yes. Now we can round it also, right? for this, which one we will round off?
Sir, initial only we can know. Hourly rate we can know.
Here we have to round out, right? NP dot round. Reset index also is there, no? No, no. Before reset index, we have to give, right? Comma 2. Yes, perfect. See how neat it is. So, where
That I told hourly rate, we can round that also.
no, no, no.
Here we can,
I don't think we can round here. We can round it there only.
it's better to round there.
That is the better option. So most of the tips are coming around 6 a.m. 6 a.m. maximum trip, lowest average tip amount is 2 o'clock, 1400 hours. So based on this, maximum average tip amount is 6 a.m. and minimum average tip amount is 1400 hours. Afternoon, right? 2 p.m. Yeah, here is the code. So we have first round off the thing to 2, and then we have plotted the SNS plot.
Our X is the code.
Which one?
Our X.
Our?
Our X.
That is the name we gave to bar plot. SNS bar plot, we gave a name as our AX.
So here also you can count
Where?
data equal to our. Here also you can count.
Hourly tip, huh? Then it's better to round here only. So that is anyway long code for rounding off, and group by bar plot is better to round off. Basically, we need the difference. At what time is the peak demand?
Only you want to show that.
Show that, yes. So easy to comprehend or easy to understand. Okay. So online guys, you are done. All right, online guys, shall we move forward? Now, let us see on which weekdays we are getting maximum tips. We will see which weekdays we are getting maximum tip. So let us find out on weekly tip. Sorry, weekday tip. Weekday tip. What day of the week most amount of tip is paid on average? What weekday most tip amount paid on average? So weekday tip is equal to green taxi dot tip amount dot group by green taxi dot weekday, right? Dot mean. So we don't need to do the PLT thing. It was 7 days only, na? Weekday AX is equal to weekday and tip amount, weekday tip, weekday AX, weekday AX dot containers. Oh. What is happening here? Okay. Data is equal to weekday tip, right? Here we have to round off, right? NP dot round weekday tip, comma 2, comma 2, close two brackets, right? This is semicolon. Ooh, you got an error. Weekday input could not interpret weekday input. Okay. So we have not reset the index, right? That's the problem. We have to reset the index also, right? Dot reset underscore index. So we got 0, 1, 2, 3, 6. So we have equal tips on 5 and 6, Saturday and Sunday. Saturday and Sunday, the averages are equal. Just when we make it 3, yeah, almost equal. Saturday, Sunday, maximum tips are being paid. Weekday tips, right? Now find out what is the other one? Is month start or is month end? Are we getting tips? What is average tipping at the month start? Is month end? Month beginning or month end? I think this you don't need to plot. green taxi dot group, only two classes, na? You can easily read them. Dot is month start dot mean 1.29 and 1.10. So false is higher than true. Similarly, green taxi dot tip underscore amount dot group by green taxi dot is month end dot mean. Almost similar, right? But month end tips payment is a little bit higher compared to month start. False is almost near, true is slightly higher, right? Okay. Hey, we have not done for day of month here. Week number we can ignore. Week number we can ignore because we are doing anyway daily, na? But day of month is important. Which day of the month? But okay, we can plot it. It's a bigger graph. 31 graph will be there. So we can see the tip amounts beginning of the month, middle of the month, and end of the month. So we can do that analysis, right? Beginning of the month and end of the month. So month day tip is equal to green taxi dot tip underscore amount dot group by green taxi dot day of month, right? Day of month dot mean dot reset underscore index. Okay, month day tip. So I will cover this PLT figure. Hey, in PLT figure, first is width, right? We will make the width to 20.
Why is not the axis side?
Huh?
Width is first one.
That's what.
Second one.
X is equal to day of month. Data is equal to month day tip. This is month AX. This is month AX. This is month AX. We got 31 days, right? So we have to do NP dot round. NP dot round comma 2 comma. So we got the tips. Maximum tip is paid on 29th, followed by 28th.
The container.
First values, no? We are plotting the container 0 is your bar label. No, not like that. Container square by 0, comma 1. Container will have two data points, 0 and 1. 0 is your month label, One is your day of month. But we want the label as what? We want the label as the value, right? Hmm.
Then all the index are gone.
That's what out of range index will come. So,
From first index, it is showing
the last index. Color palette we can give. Color palettes, what are there? That's what. No, just let me do. Color is equal to, we have na SNS bar plot.
we can create our own color list.
Palette is there. Color and palette is there, right? One second. Let us see the command in Google once. So Cbound thing, we have control F color. Matplotlib color only. Pastel is there, hustle is there, set2 is there, flare is there.
In the palette, you with just columns, if you do anything, if you write anything, there is an error coming. There are many colors are there. You can choose one color.
So what is that? You said palette is equal to
Anything you can write.
In column.
in column.
But XYZ, right? Just XYZ or anything. It
XYZ.
will give a error. And below that error, we can choose one color.
This is the thing, na. That's what color is that. I know. Cool. Cool. Right. We have a lot of color palettes, right? Rainbow is there, no? Let's see rainbow. Yeah, it's good, better trick. But this is what we can do. Then we have done these categorizations and group bys, VDA. Next, what we can do? Next we can do is strip type. What are the categorizations? So green taxi dot tip underscore amount dot group by green taxi dot trip type dot mean. 1 and 2. Trip type 1 and trip type 2. Payment type green taxi dot tip underscore amount dot group by green taxi dot payment type dot mean. 1, 2, 3, 4, 5 type. Negative means are also plotting. 2 is 0. I think maximum payment type is cash only. Credit card.
types. The first is predictor.
Okay.
The second is cache.
Second is cache. Okay. Now green taxi dot columns. So numeric calls, we can do manual thing. Numeric calls is equal to green taxi double square bracket passenger count, trip distance, fare amount, MTA tax, tolls amount, surcharge, total amount, right? Control C. And then what else we can do? Do we need to add anything to here? I think we have to add travel time also, right? Rest of all are categoricals. Travel time is numerical only, right? Passenger count, trip distance, fare amount, sorry, extra, MT underscore tax, these are all numeric calls. So numeric calls dot head. So we have data 1, 2, 3, 4, 5, trip distance, zeros, travel time 9.83, total amount, all some things are there. Okay. So you did SNS.core plot, right? So SNS dot heat mapper or plotter CO. Oh, okay, we have to give the data frame and then write numeric calls dot CO RR parenthesis, yeah. So we got which values? These are correlation values, na? So we have to look for. See, this is what we have to look for. Which one?
Give n not equal to 2. Then it will show that
Comma
a and then
A and A naught is equal to 2. But this is zigzag, na? This is not the right method. Instead of that, we do a correlation plot and do this thing. That would be better option.
We can
Okay, you are saying figure size increasing, it will give clearer. Oh, sorry. Cell, undo cell is there.
on that cell, we can go and control that cell.
No, it's not working. This one, huh? No, it's not working. So you are saying PLT dot figure fixed size is equal to 15, 10. Then SNS dot heat map numeric calls dot CORR comma and not is equal to true. Now it is clear. No, color is okay. We are looking for high correlation. There is no multicollinearity, right? Here 9.7 is there, 9.6 is there. What is this?
MTA tax and surcharge.
Oh, multicollinearity is there, na? 97. This is also there. This is 9.6, right?
87 also.
87 is not a problem. As long as this is about 95, then it will clearly lead to multicollinearity problem.
But sir, as per the story,
Ah.
above 0.7, it is taking the high correlation.
No, I am not talking about high correlation. I am talking about multicollinearity.
Multicollinearity.
We are looking for multicollinearity only, na? My multicollinearity threshold, threshold value for multicollinearity indicates the presence of multicollinearity, 0.7 and above. Oh, 0.7 itself is multicollinearity, yeah? But 0.7, I never saw it is giving us any problem. Overfitting comes when the collinearity is about 9.9. I have my personal experience. So here,
So for me, I found around 3 or 4 high correlation, positive high correlation.
see, fair amount and distance, there is correlation.
High correlation.
But that will be obvious, right? That is obvious. We can't delete that. We cannot ignore that one. So that is the only thing. The other 97 is 0.97 is improvement surcharge and
MTA tax.
improvement surcharge and MTA tax.
These two things also we cannot ignore.
You cannot ignore.
Because
But anyway, it is not going to affect our linear regression, right? R square is not that high.
there is 0.9997 is correlation.
That is a correlate. That is overfitting, no?
Yeah.
So we have to look at these ones.
Yes.
Okay, first we'll build and then see what is going to happen. Numeric calls. This is the numeric calls.
Second, you scroll.
Pardon? Hello. The third floor reception में दे दो. Third floor में आके reception में दे दो. Hematicus learning. Hello. For what? That's label encoding, no? We do label encoding, simple. Dict key values you can give, but anyway, end of the day you have to label encode, right? End of the day you have to label encode even after giving the dict. So why do all those things? We will directly label encode. So we can say strong correlation. Ramakrishna. Good morning. Second question. అవును పర్లేదు కదా ఓన్లీ 10% కదా ప్రాబ్లం అనా ఓకే సరే ఓకే total underscore amount and trip underscore distance, which is valid reason, right? Trip amount and distance, it's valid reason. Strong correlation between trip distance fair amount and total amount, right? Fair amount and total amount. We can delete one of this. I think we can delete fair amount. We'll take total amount.
Which one would be
9(7) is what? MTA tax and improvement surcharge.
you cannot go ahead and
1 second. That is okay. MTA underscore tax and what is the other one? Improvement underscore surcharge.
Yes, sir. In interview, we asked about the negative angle correlation things.
Hmm.
So can we ignore that one?
It depends, na, whether there are no negative correlations here.
Minus 0.81 is also there.
Where,
If you will say trade type and improvement surcharge.
okay.
MDA tax and trade type also.
No, trip type you should not have here, na. Trip type is a non-numeric variable. Otherwise, I don't see any, negative correlations are there between improvement surcharge and travel time. Okay, negative correlation, I can see one between improvement surcharge and travel time. Negative again, MTA tax and travel time. And then MTA tax and total amount. Then improvement surcharge and fair amount. See, negative correlations, if it is with dependent variable, Madhav, you can do it as a feature selection.
Yeah, which is
If it is related to the dependent variable. But if it is between independent variables, then we have to look at the variable and decide. Negative correlation between dependent variable, I think we can use it as a feature selection method. That okay.
Both things are very good.
Yeah.
Fair amount and
Fair amount and total amount. No.
total amount and
No,
total.
no. Total amount and trip distance, fair amount and total amount, MTA tax and improvement surcharge. Only 3 strong correlations are there.
And this one, fair amount and
Fair amount and oh, 87 is also there, huh? But 87 is total amount and fair trip distance, na?
fair amount also.
Where it is fair amount? Fair amount and trip distance. Then we can see. Then we can take only one of them. We can delete fair amount. Trip distance. Strong correlation between fair amount and no. You have to see. You have to choose between total amount and fair amount. You have to choose between total amount and fair amount. That is the point. Okay. So trip type is 2 categories, right? Trip type is 2 categories, right? So as null, the average tip underscore amount for different trip underscore type equal test null, the average trip underscore amount for trip type is equal. So green taxi dot trip amount, sorry, dot group by green taxi dot trip type dot mean. So we have two trip types and the means are different. We also have to check variance, right? Dot var. Variance is also different.
Sir, you told that if it is mean, the differences in mean, then no need to check the.
Because here we have to give equal underscore var false, right? Obviously, you have to check it. To avoid that discussion, it's better to check it, right? From scipy.stats, import test underscore int. But before that, we have to split now. Trip type 1 is equal to green taxi square bracket green taxi dot trip underscore type double equals to 1. Trip type 2 is equal to green taxi square bracket green taxi dot trip underscore type double equals to 2. Okay. Test underscore end trip type 1 dot trip amount comma trip type 2 dot trip amount equal underscore var is equal to false. So what we are doing here, since p value is less than 0.05, reject null. What is the null? I didn't write the hypothesis. No significant difference in average tip amount for different tip types. Tip underscore type. Null is no significant difference that we are rejecting. That means the difference in means is statistically significant, which means the difference in means or averages is statistically significant. The marginal difference is statistically significant. We have marginal difference, right? 1.13 and 0.86. That is statistically significant based on the trip type. So trip type is a critical variable we have to include in our model.
We cannot leave.
We cannot leave. Then trip type and total distance. Total distance. Either total amount or total distance, trip distance. Oh, I didn't do the group by R. Green taxi dot trip underscore distance dot group by green taxi dot trip type dot mean, because there is correlation, na? See, fair amount and trip distance we have correlation. Okay, fair amount and total amount we have correlation. Total amount and trip distance also we have correlation, na? So anything will work. So if you want me to take total amount You can take total amount also if you don't want to take trip type. Sorry. Here. Okay, 13 and 18. This is a little bit bigger. Okay. So let us do the total underscore amount, comma, trip type 2 dot total, sorry, underscore amount equal underscore var is equal to false. Reject null hypothesis. The difference in means is statistically significant. Even for the other, even if you take trip distance also, it will come as statistically significant only. See? Big variance. Right? Okay. But whatever it is, we have to put it as false now. You have to reject it. That equal underscore var is equal to false. Got it?
That these things can affect if we will treat the outliers.
See, outliers treatment, I tell you now, you can't treat them.
Very large.
Oh, obviously, no, trip distance and money will differ, right? There's a valid reason for outlier, agree or not? See, in insurance claims, you will have 1 or 2, 3 or cases where it is larger value, but most of them will be in minimum value. But look at sales of store sales, you will obviously have outliers, right? Some stores will definitely perform very good. Same thing here. Here, some trips are very long. Will charge obvious reason the amount has to be higher. How will you cut it down? That means you're wrongly presenting the data, right? If you cap it or if you replace it with mean or median, that gives you the wrong interpretation, right? That pattern has to be taken into the modeling. That there will be some high fare or high total amount trips will be there always. Always there will be high total fare, total amount will be there.
So it's upon the business case.
It has to be taken as data to data. Upper. This.
then the variance cannot. But here we see that the variance is different.
By default is equal underscore var is equal to true. Because
T-test and hypothesis.
no. See here. See here. Here, what it is saying by default is, but actually, what is our data saying? Is it true?
No.
If you don't give it, it will assume that the variance is true. Equal underscore variance true means it will treat both the variances as same. It will affect the p-value. Now, is it variance same?
No.
No. That is why we have to specify equal underscore var is equal to false. Because by default it assumes as true. Even in Excel, you remember t-test 2 sample assuming equal variances. T-test 2 sample assuming unequal variances. In Excel, if you remember our Excel also, we have two functions. The Excel t-test functions in the data analysis tool pack. If you remember, we have done it at the beginning of our sessions. Data tab, data analysis tools. See, data analysis. You see here, there are two sample t-tests, assuming equal variances, assuming unequal variances. In reality, it will be always unequal variances.
The variance equal to, we will check if the variance is equal.
Ah.
Then we can
We don't need to give the argument as false. We just need it to, by default, it will take it as equal underscore var as equal to true. Because it will affect the outcome. So two sample t-test, you have to be very careful when you're doing this, particularly two sample t-test. Got it, all of you? T-test you have done, split the amount and done. Total amount t-test. Yeah, for all numeric calls, you can do one box plot, right? In SNS. For loop we have to use, no, directly for loop. So for I in dot columns and it will give individual box plots, no? But we want all in one box plot.
With respect to, kind of like that,
No, that we can do. That I know. See, month wise, day wise, we can plot it different bar plots in one. But I think we can't plot all of them in one axis because the numbers are different. We have to plot them individually only.
One axis, one graph, and it is showing different lines.
Okay. No. The one, see, we can do a bar plot for tip amounts on month, that what you call weekdays. That has to be in one single plot only. Based on a categorical variable and numeric variable, we can plot them in one single box plot. Okay, you can do this plot. SNS dot cat plot x is equal to sorry, x is equal to weekday, right? We have a variable called weekday, right? Weekday, comma, y is equal to tip underscore amount, comma, data is equal to green taxi, comma, and is equal to box. See, all of them are skewed to one side. Instead of tip amount, if you take total underscore amount, we will get a better plot. A very big outliers on both sides. We have outliers on both the sides. Where this is quartile plot, interquartile range. How you will create box plots? IQR can be negative, right? Okay. So total amount, tip amount, these are your categorical plots based on X and Y. Okay. So you can try at home additional things like you can do these hypothesis testing. Test null, the average tip underscore amount of different weekdays equal ANOVA you can do. Then you can also check test null, the average trip underscore distance of different weekdays equal is again ANOVA. Then test null, no association between type and weekday. Is here what test? Test null, no association between trip type and payment underscore method. Payment underscore method is also there, right? So payment type. Payment underscore type. Okay, we can do this. ANOVA and chi-square test. Okay. Then you can also do categorical box plots. You can do categorical box plots for categorical box plots for any other variables you can do, right? Two variables, categorical box plot you can do. So categorical box plot for weekday and tip underscore amount. You can also do categorical box plot for week number we had na? Week number and trip underscore distance. think he wants to talk to you. Guys, 1 second, stop recording.